So what do we require, right? I mean, if you want to get high quality content from this corpus, from the raw data, then we require to detect the language of the web pages, right? So suppose you are building a corpus for Hindi, you only want to take those web pages which have Hindi content and ignore the others, right? So you'll have to detect the language of the content on the web pages. So that's some kind of a language identification you need. Then you need to deduplicate the content. I've said this enough times that there's a lot of redundant content on the web, so we need to make sure that we just take the single original or single copy, maybe not original, but the single copy of the same content and don't keep repeating it. And we need to detect toxicity level, which could be of different types. It could be hate speech, bad words, some stereotypical comments or write-ups, and we need to get rid of all of that. Now, to what extent we can do is not really clear, but at least an attempt should be made to get rid of some of this content. And of course, there is also opinion that some of the content should be left as it is, right? So that the model can also understand what is toxic. If the model has never seen any toxic content, then in downstream applications, how will it understand and how will it learn to deal with it, right? So if I remember the Llama 2 or the Llama paper, they had said that when they cleaned up the data, they had retained some toxic content as it is in the pre-training data, right? We also need to detect the quality of the content in the pages. So this is where things like if the web page is just like a stub, right, and they have just put some placeholder content without anything meaningful, then you want to get rid of it. If it contains machine translated content, then you need to get rid of it, right? It's just a spam spurious website, then you don't really want to use it, right? And you have some reference like good content is like Wikipedia kind of content or books content or archive.org content. So does the content of this page look like some of the good pages that I know of? If not, maybe I can remove it. So that's one approach. The other is just to have some heuristics that if the page just contains a lot of templated content which does not make much sense, then you could remove it. And we'll see some of this in more detail, right? And of course, an attempt should be made to remove PIIs. Again, it's not clear how elaborately you could do it or how exhaustively you could do it. Can you ever be sure that all PII has been removed? It's not clear, right? I don't think that's completely possible. Okay, so now what do people do for each of these, right? So for detecting language, there are several language detection tools or libraries available. All of these are open source. For example, people use something on top of FastText. There are libraries released by even a Meta on the as a part of their No Language Left Behind work. We have also released an Indic LID, which works better for Indian languages. To deduplicate the content, you could use standard deduplication algorithms. Of course, exact match is difficult, right? So suppose I have billions of pages. Now I have one article, and I cannot compare it to all the billion articles to say that this is exactly equal or not, right? So you need some kind of hashing based approaches, sometimes even ML based approaches. So these are like well studied problems, right? This is not an LLM problem per se. Deduplication is required in almost all contexts, in multiple contexts, right? So these are all well studied areas, and what we do is just look at some of the well-known algorithms from that literature which allow you to deduplicate content and just take them as it is, right? For toxicity, again, either people use simple heuristics or sometimes use a language model to decide that this is toxic and so on. Similarly, as I said, for content in web pages, you could use simple heuristics. Does it contain some stubs which are known to be bad, or is it, you could even try to compare it with reference text like Wikipedia and so on. And for detecting PII, you could use regex patterns. So anywhere you see an email address at the rate, you could sort of remove it from your data, or if something looks like a phone number, you could remove it from the data, but only to an extent, right? You can't remove everything, right? So deduplication, there's two types, right? So now we'll try to focus on all these 5 items written here, right? Which is language identification, deduplication, something around quality, toxicity, and PII, and see what we can do about it. So starting with deduplication. So there are two types. You could do exact deduplication, right? And so this is an example that you have web page 1, web page 2, which are exactly the same content. But then you would also want to remove near duplicates, right? So you can see that both these sort of paragraphs on the right hand side, they're originated from the same content, right? Someone has just done a bit of paraphrasing or a bit of change in the text, but it's not adding any new information, so you would want to get rid of them, right? And for exact deduplication, as I said, deduplication is a well-studied problem, so you just use solutions from there. So there's suffix arrays that you create, and then sort of try to find duplicates using that data structure. Or you could do fuzzy deduplication, wherein essentially you take the article, you compute some hash of it, and now take a new article. So if you have billions of articles, for every article you just take a hash. Now you take a new article if its hash is similar to the same as the original, same as one of the already hashed articles, then sort of that will get there will be a collision there, and you can drop one of the articles, and you can have different thresholds and so on, right? So this is a very well studied area, and there are multiple well-known algorithms there. So people use one of these, right? So let's start with the basic pipeline, right? You took the common crawl dump, you did language detection, you found out articles from different languages, then you did deduplication using hashing, because as I said, exact matching is very expensive, so you'll typically end up using hashing based algorithms. And you have done deduplication at line level, right? So maybe every sentence or every line you have hashed and then removed content based on collision, right? Now this satisfies only 2 of the 5 things that we wanted to do. We have done language ID and we have done deduplication, and it still does not, the text could still contain toxic, low quality and PII content, right? So there's this CCNet pipeline, which is designed for extracting high quality monolingual pre-training data. So earlier we had seen like the book corpus and Wikipedia, which is largely for English, right? Wikipedia does exist in multiple languages, but there is a huge drop in the amount of content available in low resource languages, right? It's almost 100, if not 100, in fact much lower than that for Indian languages as compared to English, right? And so for example, Hindi has only 1.2 million pages, Tamil has only 0.5 million pages, whereas English has 59 million pages, right? So this is quite a bit of a difference between the languages. And this is counting all pages, right? Because there will be some repeated versions of the same pages. So if you look at unique articles, then the number is almost 1 order less for all of them, right? And therefore we need to use CC dumps, right? We can't just rely on this Wikipedia, book corpus, etc. is not even available anymore. Therefore this complete dump of the web is what we need to start with, and then sort of get the content that we want. And this requires massive parallelism, right? Because you are dealing with a very, very large amount of data to begin with, and it's going to take a lot of compute to do it, but fortunately not GPUs, but a lot of CPUs to get it done quickly, right? So what the CCNet pipeline does is it starts with paragraph level deduplication, right? So divide each web page into 3 parts, head, middle and tail. So this is what it looks like. And then you obtain quality scores for each portion, right? So you say, okay, what is the quality of this portion, and now even if you read this and if I ask you how would you rate it, then probably in your head you're thinking that the last part perhaps has a better score than, at least the first part looks wasteful, right? It doesn't seem like it just is some list of menu items and so on, right? So if you were to have a pre-trained language model which has been trained on Wikipedia, and you try to compute the perplexity of these portions using that language model, right? How likely is this sequence to be generated by that language model, which is good at generating Wikipedia style pages or any good content style pages? And then obviously some of these portions would score poorly, and then you will sort of get rid of them, right? So that's the classifier that you're using. You get a quality score, then you will have some sort of a threshold, right? So first thing you will do is remove the low quality pages based on threshold. Then you can do deduplication using hashing, then language detection, and then some more quality filtering on top of that, right? So now this is the pipeline that you have set up. You already had deduplication and language detection. Now based on this pre-trained language model that you had, which is good at saying that this content does not look like good content, because I am used to generating good content which looks like this, and the content that you are giving me is not looking very good according to me. So that's the targeted quality filtering they do. So you have added one more stage, right? So now out of the 5 things that we wanted, we have 3 things done. And now this pipeline they have used for extracting data for 130 languages, right? And that's quite a bit. So the same pipeline can be used language agnostically, because now you have a language detection stage inbuilt, right? and if you look at the data in that they were able to extract, right? So using this pipeline, they were able to extract data from multiple languages. So you have English at one end, which always sort of overshadows everything else. So it had 550 billion tokens. This graph does not even show all the languages, but the last language here has some 1.5 billion tokens, and I don't see any of the Indian languages showing up here, right? So that means there were even fewer than 1.5 billion tokens for Indian languages as extracted by this pipeline, and they had done this on the February 2019 snapshot of Common Crawl, right? And if you remember, Tamil had zero point 0.5 million Wikipedia pages. This is again a bloated number because you're looking at all versions of the pages, but if you just look at articles, then it's 1/10 of this, right, roughly. But using the CCNet pipeline, one could get 0.9 million documents. Of course, there will be some overlaps with Wikipedia, but at least you are able to get 2x more content. Now we look at the C4 pipeline. So as you had said that for some of the datasets the pipeline was known. So now we look at the C4 pipeline, which is again similar. You do language identification, then you do deduplication. They had 9 different filtering heuristics, right? So these are all things like, okay, if the web page has X, throw it away. If the web page has Y, then throw it away. So you're throwing away a lot of content and then sort of deduplicating it. In the absence of those heuristics, you can see that the size of the data was quite large. It was 6 TB. But after adding those heuristics for filtering out content, the data size decreases quite a bit, right? And they could also get diverse data such as news, stories, web text and all. So they filter for specific domains, right? So they say that, okay, we don't want a lot of content which is not news-like, so just take out the news domains and then you get a news version of it. Then you could take more like the web text, which is web pages as opposed to only news content and so on. So they were able to take some domain filters and then say, okay, this page looks like a news page, so put it in the news bucket. This page looks like more like a web kind of content, so put it in the web text like bucket, right? And yeah. So now what are these heuristics that we were talking about, right? And I've taken this from the talk of Colin Raffel, who was, I think, the first author of the paper. So this is an example, right? It's not clean, right? So you have this boilerplate text like menus, right? So you have this menu, lemon, then you have home, products, shipping, contact, FAQ. You don't want this. Then you'd also have offensive language or some placeholder content. So as I was saying, just some, you can see the lorem ipsum standard placeholder content here. So you don't want that. You also see some code written in between. You perhaps don't want that. You can choose to have a code, a dataset as a part of your pre-training data. But here at this time, people were not using code as a part of the pre-training, right? So then that also you need to get rid of. And sometimes the code, it may not be like a real code from a coding website. It might just be some sort of a dead JavaScript which is showing up, or some sort of a broken HTML which is showing up on the web content itself or the web page itself when you have extracted it from a HTML parser. The parser may have wrongly extracted that piece of code also. So that you want to get rid of, right? And you also want to filter out for low quality and so on. So some of the filters that they use, right, is that remove any page that contains a lorem ipsum kind of content. So this entire page goes away, right? So that's, if you remember, that shown the sort of a drastic reduction in the size when they had applied these heuristics based filtering. So this is the kind of one such heuristic that they had used, right? The second heuristic is remove lines which do not have any terminal punctuation marks, right? So this would typically get rid of content which is not like a paragraph or a written content, right? It's just some menu items, some date bylines, or some headers and footers and so on. So all of this will get removed because it does not have a terminal punctuation mark, a full stop or a question mark or an exclamation, right? So you can see a lot of content gets pulled out there, right? Then deduplicate the text. So they found this some text which was already there on a previous website, right? So they have removed that content. And then they remove toxic content by having a manually created list of bad words. Any page that contains a bad word is removed from their entire training data, right? So the entire page is removed even if it contains some bad word, right? So now this pipeline sort of has almost everything, right? So it has the deduplication, it has the language identification, then it has some kind of quality filters, although heuristics, not machine learning based or not trying to use a model to detect something is of good quality or not. just simple heuristics to get rid of bad content. Also some kind of toxicity filters, right, to get rid of pages which have bad words. So in general, all the pipelines follow the same structure with modifications to the components, right? So for example, the pile folks start with the WARC format instead of the WET format, and then they, which contains the HTML pages, right? And then they use this library called JustText to just get the the text content from the HTML pages. So it gets rid of all the HTML code around the main text, right? So they use that to extract text data. Then they do a language detection. They use a specific library for language detection. And then they use deduplication and some targeted quality filtering to get the pile version of the corpus, which is some 227 GB, right? And these quality filters are again different across different papers. Most people, at least nowadays, at least I personally, in whatever data sets we are building, we rely on heuristic based filtering as opposed to any ML model kind of a filtering. Just come up with rules just as the C4 guys had come up, which we saw on the previous slide, and just filter content based on these rules, right? And these people, at least for the pile corpus, they use the fuzzy deduplication over exact deduplication, which was used in C4, as C4 actually used exact deduplication. But actually, right, a lot of duplicates in Common Crawl are exact duplicates, right? So then what people do is that after the fuzzy deduplication, so you had this large pile, you did all this quality filtering, etc. Then you do this deduplication, so this becomes smaller. Now in this smaller set, do an exact deduplication, right? Because you know that a lot of duplicates are exact deduplicates. So if something has been left out, you can now have a smaller pile to deal with, on which you can do exact deduplication, although it's very costly. So now we have seen the CCNet pipeline, we have seen the C4 pipeline, now we have seen the pile pipeline, and all the components are falling in place. These are the 5 basic components that we had listed earlier, which was language detection, some sort of deduplication, quality filtering, toxicity removal, and bias removal. And then they also differ in the sort of method of extracting the text data to begin with. So the pile had used JustText as their extraction module, right? Now I look at yet another pipeline, which is the RefineWeb pipeline, which was a dataset released by the folks behind the Falcon model. So again, they start with the WARC format. They use the JustText to extract the text content from the HTML parts, right? And then they were focusing on English. So 50% of the content is just removed after language identification, right? So just after doing LID, they were able to get rid of 50% of the content. So they had a few more stages. So begin with, they had some URL filtering, right? So now there's a block list of URLs that people create. So anything with certain offensive content in the URL itself, right? They would just add it to a block list, and those URLs are filtered out. So not much content gets filtered there, some 2% gets filtered out. Then during text extraction, again, some content gets lost because it was maybe just a plain HTML page without really any content in it. And then you do language identification, where 50% of the content gets dropped, right? It's non-English content, and they were only looking at English, right? Then they had several other stages. So they had repetition removal, right? Then some document-wise filtering and line-wise corrections, right? So all of these were heuristic-based approaches. In fact, the paper clearly mentions that we don't rely on any machine learning-based algorithms. We just do rule-based heuristics to clean up the data, right? And then after all this, they do, after the quality filtering, right? These 3 stages are like, repetition removal is basically if the same page has a lot of repeated content, then it's probably machine generated, so you can remove it. And similarly, some heuristics they apply at the document level and at the sentence level, right? So then they remove that content also. And after all of this, they do deduplication, where they do 2 things. First, the fuzzy deduplication, and the exact, followed by the exact deduplication, right? And you can see the amount of content reduced at each stage. So starting with a very large amount of data from Common Crawl, 50% got eliminated by language identification, 24% by quality-based filters, and 12% by deduplication, right? And then they were left with a very small amount, right? The last pink bar is very small as compared to the initial blue bar, right? Almost 90% of the data got over. So now, since we are focusing on deduplication, right? So what is the impact of having duplicate content? Or suppose we don't do deduplication, because it looks like a lot of content gets filtered out during deduplication. So what happens if we don't do deduplication? So there have of course been studies on that, and we look at that. But here's a quick look, right, of the pipelines that we have seen so far. So we have seen the C4 pipeline, then we have seen the pile pipeline, and now we have seen the RefineWeb pipeline, right? And if you look at some of these are of course public and the others are private. So GPT-3 and Palm are private, and the pile, RefineWeb and C4 are public, and their sizes are also mentioned here, right? And you can see RefineWeb was much larger number of tokens as compared to the other datasets being compared here, right? And these are all web based, so all of these are 100% taken from the web. GPT-3 uses only 60% of web content, and then it uses some other datasets including code and other things. Similarly for Pile, of their entire data, only 18% is from the web, right? So we are looking at the web cleaning pipelines, and for RefineWeb, their entire data is from the web, right? At least what they released, right? And for the processing, they used rules plus NSFW. This is not suitable for work, which is essentially a list of bad words which you want to remove. And then they had looked at exact deduplication. So if they have spans of 3 sentences matched in across articles, then they would remove that. Then if you look at the pile, they had used just text for extraction, and then some filters for sort of cleaning up the data, and then minhash was used for deduplication. And if you look at RefineWeb, they use exact and fuzzy, and they had document and line level rules for cleaning out bad data. So some of the rules, I think they also use the terminal punctuation removal, right? So RefineWeb was in 2023, so by that time many of the filters etc had already been proposed, so they just use a combination of those with of course a few of their own also. So far the pipelines that we have seen, right, these are mainly about text data or web data, right? What about audio? What about scanned images, right, which is PDF documents which require OCR? They're not in machine readable format, and it's almost like a known secret that a lot of the proprietary or the very well performing large language models have been trained on a lot of YouTube content, right? Because YouTube has a large amount of content, and at least in the case of Indian languages where we have a lot of interest, a lot of content is available on YouTube as opposed to amount of content that is getting written out there, right? And one striking example is that when Chandrayaan was launched, if you would go to YouTube at that time, in multiple languages you would find so many videos uploaded about Chandrayaan, and they varied from the general euphoria to all the way very technical videos in Tamil or Hindi or any of the regional languages, which are trying to explain like what was different, why did we succeed, what were the challenges and so on. Like a very nuanced discussion on the event of the launch, right? So a lot of content actually is available in videos. So you could take the audio from there and sort of transcribe it using an automatic speech recognition engine. And a lot of content, again in the context of Indian languages, available as PDFs which are not machine readable. So government puts out a lot of documents on different advisories, or even the usual government business on say budget speeches, important bills, etc. They are all available in PDF formats, and you might be interested in taking all that content. Right? So there's a lot of content on Indian culture and other things which is available as government documents in PDF format, right? So you might need an OCR pipeline also. So now what we describe next is the Setu pipeline, right, which is developed by us for creating a pre-training dataset for Indian languages, and we call the dataset as Sangraha. So Setu can take PDFs, it can do an optical character recognition on that and get the content out of it, or it could take web pages, do some sort of verification. So we had a human verification of websites, because in the case of Indian languages, a lot of content is actually machine translated, right? So we asked humans to actually verify that if this is identified as a Punjabi website, does it actually have original Punjabi content or not? Then we wrote a web scraper. So this PDF after OCR gives us text content, The scraper, after all this URL identification, etc., gives us the text content, and then we take some videos, do a automatic speech recognition, and that also gets us the text content. Then we have the text filters, which is, as I said, this is like a something which requires massive parallelism. So we built our pipeline on top of Spark, and it has the following stages, right? So we prepare the data, then we clean and analyze. So here again we use a combination of the known tricks which are there, right? So we, for example, we look at the number of repeated lines in a document, right? And if a document has many repeated lines, then it gets filtered out, right? So we first do an analysis on the document where you try to gather different statistics, how many words are getting repeated, what is the total size of the article, and so on. And then in the filtering stage, we use certain thresholds that if a certain content was repeated, sentence was repeated X times, right, then we remove it. If the document has X sentences which do not have terminal punctuation, or we just remove all the sentences which do not have terminal punctuation. So that is what happens in the flagging and filtering stage. And after that, we do a fuzzy deduplication, and we see that starting from the original, we are left with only 24% of the initial content that we had started off with, right? And in addition to taking the Indian URLs from Common Crawl, we also had discovered our own URLs with a focused search on India-specific content like Indian culture, Indian art, Indian education, Indian history, and so on. Right? We had graduate students searching all that content, and then we added that to our web crawls, right? So we have a detailed paper on this, and we may put out some more detailed discussion on the different stages of our pipeline. But yeah, this is an overview. So again, it has all the things that are typically there in the pipeline. It has a language identifier to sort of split the data into different languages. It has deduplication at the end. It has enough filters for toxicity. For toxicity, actually, we also created a list of toxic words across multiple Indian languages and filtered out any content which had toxic material. Right? So that's what gets flagged and filtered in the filtering stage. Right? And this pipeline supports both web, videos, and digitized PDFs. And we use Traffilatura. So as I had said earlier, this is this JustText library. That's similarly, there's a Traffilatura library available to extract content from HTML web pages. And we used our own language detection, which is indic LD, and also in combination with other LIDs like CLD3 and NLLB, which is from Meta, and then we did a fuzzy deduplication, right? So all these stages of the pipeline are there in Setu itself, right? And this Sangra is the dataset which comes out of it, which is India dataset of pre-training data for Indian languages. Okay, so now that we have covered multiple pipelines, right, and the stages were similar across those pipelines. They just vary in the number of filtering rules they used, or the manner of filtering, whether it's rule based or machine learning based, and so on, or how big is the toxicity list, whether they used a block list of URLs or allowed all URLs to pass, and so on, right? But despite that, like now, I want to spend like next 4 to 5 minutes on saying that none of this is perfect, right? So, example, if you just look at deduplication itself, it is very difficult to do perfect deduplication, right? Because at that scale, you cannot run exact deduplication, and you might miss out things, right? And you would also want to have a threshold on whether you want to look at duplicates. Suppose only 50 words in 2 articles match. Do you want to flag it as a duplicate or not, right? So that's also a call you need to take. And if you look at the C4 corpus, right, which was fairly refined, there was a single sentence with 61 words, which was repeated 60,000 times in C4. That looks like a lot of repetition, right? And not only in C4, happens in almost all the datasets and other datasets like real news. So this is a comparison of different datasets, and all datasets have a significant amount of duplication, right? So real news has almost 20% duplication, right? And even the pile dataset, which is again considered to be one of the better datasets, or at least when it was released, it has a lot of duplicate documents, right? And it was advised that researchers should further filter it, and that's why when Falcon came out with the RefineWeb, there was a significant emphasis on deduplication there, where they did a fuzzy deduplication and then an exact deduplication. So it's become a norm, but many of these pipelines still some duplicate content goes out, right? And therefore the natural question is, does deduplication really affect the performance of the model? So there have been some studies around that, right? So Why is it important? So if you have a lot of duplicates, what will happen is that the model will memorize the training data, right? So if there is one poem that appears, just for the sake of argument, a million times in your training data. Now, if you ask the model to write a poem, it's very likely that it will generate that poem more likely than any other things that it might write, because it has completely memorized it, right? And it gives a wrong picture of the test performance, because now your model has memorized the training data, so you feel okay, it's doing really well, but on the test data it may not do very well, and it's also susceptible to privacy risk, because now if the model is memorizing a lot of email IDs or any content which has appeared multiple times, then it can sort of reproduce that as it is, right? And there are studies which have shown that for a 1 billion parameter model, if you have 100 duplicates, then it's harmful, right? Even 100 duplicates are harmful. What does that mean? That the model performance decreases at test time on certain tasks. And for a 175 billion parameter model, even a few duplicates could have a disproportionate effect, right? And these studies are, of course, in some sort of under some assumptions, under some conditions, right? They're not like elaborately testing what happens if you do duplicates. They create certain scenarios and say that, okay, in these scenarios, the duplicates were found to be harmful, right? And now if you look at the graph for C4 here, so on the x-axis, you have the number of duplicates in training data, right? So the number of, on the x-axis, what you have is that the number of times that sequence was repeated, right? So they're looking at 400 character sequences, and if I look at this bar here, so this or maybe this bar, sorry, this bar here, then it corresponds to 10 raised to 1. That means a sequence of how many times was it the case that a sequence of 400 characters was repeated at least 10 times in the data, and it looks like more than a million times, right? So this is 10 raised to 7, close to 10 raised to 8. So more than a million times it has happened that a sequence of 400 characters was repeated more than 10 times in the data, right? At least 10 times in the data set, and which does not seem reasonable, right? Why would you want to do that? So same 400 character sequence is fairly large. Why would you want it to be repeated, right? And then this is also, as I was saying, in line with studies, and why this is like harmful is because studies have shown that if you repeat a sequence 10 times in the training data, then on average it will be generated 1000x more times than any other sequence, and that's the poem example which I was giving. If you just keep repeating the same content, then the model sort of has very high probabilities for generating that content. And so all pipelines have their faults, right? And multiple studies have shown. So this is the pile. This is a comment on pile where it was said that it contains a lot of duplicate content, right? And then these are studies which show that if you have a lot of duplicate content, even repeating a small amount of data 100 times, while ensuring the 90% of the data is unique, but you have taken some 0.1% of the data and repeated it 100 times, then the performance of a 800 million parameter model becomes same as that of a 400 parameter model, right? So that is bad. That means you're training larger models, but you're repeatedly showing the same content, so their performance would be as good or as bad as a smaller model, right? Even Gopher had their own observations, so they had a slightly different take, right? So that's why it's not very easy to take these decisions. So now when you're trying to build a high quality data set, now one of the sort of recommendations or observations that they made is that if you train a classifier on Wikipedia data and say that reject everything which does not look like Wikipedia, then you'll not have enough diversity in your data, because Reddit content, which should be useful because a lot of interesting content gets posted on Reddit. Of course, now Reddit has banned people from taking their dataset and training LLMs, but at that time it was there. So if you take Reddit content, right, and if that would look very different from Wikipedia style content, but it's not wise to reject it because it also has a lot of good content. So then you will always have one style of content which is everything that looks like Wikipedia is good data, and I'll train on everything which looks like Wikipedia, and so there will be not enough representation of other kinds of data, right? And similarly, this very useful article called a pre-trainer's guide, they say that a high quality academic paper, suppose you train a model which only allows things which look like Wikipedia or archive papers, then again a Reddit post which is a very high quality is going to look very different from an academic paper, and you don't want to reject that just because of that, right? So you have to have better ways of identifying what is good data, right? So that's the overall idea, right? You're doing a lot of stuff on building these pipelines, and you're taking best decisions in that point of time, but then in hindsight, some things might not turn out to be so good, right? So this is all still evolving, and current best practices are being implemented, and at least some of these pipelines are open source now. And so you could use that to create datasets for other languages, while being mindful of constantly being updated with the literature on the comments of whether duplicate content should be allowed, whether only very high quality Wikipedia kind of text should be allowed, or there should be more diversity and so on. Right? Okay, so we'll end this video here. And now that we have looked at the data pipeline, we'll come back and look at some of the existing datasets out there.